Here they are, our next two candidates we're going to play with. I said now we're going to make some noise. Hello and welcome to the Noise Factory. This here are two buzzers, they are called. Why they are called buzzers? We will see. One of these buzzer is a so-called active buzzer and the other one is a passive buzzer. Which is which, we will see if we apply voltage. So, let's see, ground, plus 5 volt. Apply here and apply here. Ooh. Okay, so that's the active buzzer. You see, I just apply 5 volts and I can hear a beep. It's not inconveniently loud, I have to say. I will cover it with the sticker it originally came from. It's better? Yes. We can still hear it. Now we'll remove it. Give it disco. Bust. This is the active buzzer. As soon as I give it some voltage, it will start to beep with a certain frequency. We heard it, beep, 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 beep. This here is the passive buzzer. Now let's see what this is doing. Not much, right? I will try to bend to the active buzzer so that you hear it a little bit better. Click, clack, click, clack. That's it. Not very much. Yeah, this is because this only makes this membrane in there only makes movement according to the voltage. If the voltage gives a certain frequency, this will swing in a certain frequency. So if it's clicking. Yeah. Here I have to give a certain frequency. Here it's enough to apply voltage. I think it's rather easy. It's rather easy to guess how to control them. So I will now make the mesh connection, the ground connection. On both. Good. And here I will use this output number 3. Okay, so that's it now for the active buzzer. Okay, that was the hardware setup. Save this under decent name. Which number? 19. Passive buzzer. Okay, so define bus bin. Bus bin is bus 3, and I of course say the pin mode of bus bin is output. And I will then say digital write, pass bin high. Now it would make a noise. Then I will make a delay 500. Then I'll make it low. Then I'll delay 1000. Let's hear how this is sounding. What is it? Invalid pre-processing directive. Define. Yeah. Okay. Typo. This is it. Okay. So you can either turn it on and off, and you can make it faster or not that fast. Yeah. I will disconnect here because nobody wants to hear this. So for instance, 500. Now I'll make it 1000. Let's hear how this is sounding. Yeah, exactly as we would expect it. Yeah, for me it's a little bit too long. I will simply modify this. Download, upload. I will never get used to this. Okay, this is how it sounds now. Okay, one thing we could do with this, we could use Morse code. So you could use Morse code and Morse your name, for instance, or SOS. This would be your task. Okay, use the active buzzer and make some Morse code. You could use SOS, short, long, short. You could use your name, whatever you like. Just an E is not enough. So this is the goal now for the passive buzzer. I'm plugging in. You hear? That's the SOS sign. Okay, so that's the passive buzzer thing. Just some Morse. Okay, that's the passive buzzer thing. Good. So that's it for the passive buzzer. Let's come to the active buzzer. Yeah, I said okay, there is this certain frequency. Maybe someone could come to the idea and say, okay, I am using, save under decent name, save as 20. Active buzzer. Yeah, some could say, okay, I don't use digital write, I use analog write. Yeah, so let's hear how this is doing. Yeah, so we'll make an integer. Then we'll make a for loop for I is 0, I smaller than 200, smaller or equal, no, smaller than 255. Yeah, I plus plus, and analog write pass bin I. Okay, so climb up. Here we delay only 100 milliseconds, so every 100 milliseconds we should get another tone. Okay, and then away with this. Then we have to go down from 255, bigger than 0, minus minus. So what we would expect now is to hear a tone from this. Yeah, let's hear. It's always the same tone. It's always the same tone. Okay, why is that? Because if you remember what I've said, at the analog outputs, they are working with a constant frequency. The only thing which we are changing is the load cycle, so the cycle between the pause and the length of the, but it's working with a certain frequency around 500 Hertz, and this what we hear now is around this 500 Hertz. Okay, and because it's sometimes it's loud, it's not that loud, it depends on the ratio of the simply on the ratio of the pause and the length. Okay, so this is not working. This way it is not working. Okay, there is a command specifically for that type, and this command, I will also disconnect it. Boy, that's annoying. This command is called tone. Okay, so this time I will tone at the bus pin, and now here we have to write the frequency. So this time I will start at 30 Hertz and I will go up to 4000 Hertz. Let's make a delay. And there is, to stop, I have to write noTone. Okay, here we are ramping up. The same thing I'm using to ramp down. I will just remove this noTone. Just want to ramp it up, and here we are going from 5000, 4000 to 30, down to 30. Okay, let's download. Let's hear how this is whistling. And you hear? It's getting higher and higher, the tone. Okay. Every time 1 Hertz higher. Okay, but it's always playing. A tone is always playing. If I'm using no tone in between, and then delay again. Well, sounds like it would explode every minute, every second. Download. Pass. It's not pass out. Of course, it's not pass out. It's pass pin. Let's see how this is sounding. You hear now it's separate tones. There's a pause in between. This is what this noTone is doing. You hear it? Yeah, so that's the passive buzzer. So the passive buzzer needs a little bit more effort in coding, but we can do quite something. Yeah? Your task is now to play a little tone. It must not really be a melody, yeah, but maybe try to play a tone ladder. Yeah, do re mi fa sol la si do. Do re mi fa sol la si do. La, 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 la. Yeah, this is why I'm a technician, not a singer. Okay, and this is now the goal of our melody, of our passive buzzer. Release the reset button. Wonderful, wonderful. Yeah, should not be exactly that melody or exactly some melody, but it should get you a hint that you understand what you're doing. Okay, passive buzzer. This is the goal. Ha! Yeah. So that's about making some noise. Okay. This thing here, yeah, yeah, we could use it as a park sensor. Pretty easy. Yeah. Here something is close, measure the distance somehow. We will get to know how to measure the distance, and manipulate the tone and the height of the tone. Alarm, alarm, alarm. Yeah. Yeah. So that's about the noise making. Next time. Next time we are going to talk about. Right now we're turning on and off little noise making things. We're turning on and off little diodes, something like this. Yeah. What if we want to turn off a little bit more? What if we want to turn off and on, I don't know, a heater or a motor or something like this? I mean, I hope it's clear for you that the output of the Arduino is not really capable of running a washing machine or a heater, or I don't know. There is not. I mean, what is the maximum current here? 5 millivolts or something like this? Yeah. Well, it's too less simply. Yeah. So we need to somehow uh, make it stronger. And this is the thing we are talking about next time. How to switch a thing which may switch some stronger or some more power. So that's the topic next time. For this time, thank you very much for listening. Yeah. Goodbye.